What comes to mind when you hear the word robot? Do you picture a humanoid machine from a science fiction movie, or maybe a robotic arm assembling cars in a factory? Robots are fascinating creations. They capture our imaginations and push the boundaries of what's possible. In simple terms, a robot is a machine designed to perform tasks automatically. These tasks can be simple, like vacuuming a room, or incredibly complex, like performing surgery. Robots come in all shapes and sizes, from the tiny robots exploring the human body to the giant robots used in manufacturing. There are industrial robots used in factories to assemble products, medical robots assisting surgeons with delicate procedures, and even exploration robots venturing into the depths of space. Each type of robot is designed for a specific purpose, but they all share the common goal of automating tasks and expanding our capabilities. Just like humans, robots need certain components to function. These components work together to allow robots to sense their environment, process information, and perform actions. First, we have sensors, the eyes and ears of robots. They provide information about the surroundings, such as distance to objects, light levels, and temperature. Imagine a self-driving car. It uses cameras to see the road and other vehicles. Next are actuators, the muscles of robots. Actuators convert commands from the control system into physical movement. Think of the robotic arm in a factory. It uses motors to move its joints and manipulate objects. The control system acts as the brain of a robot. It receives information from sensors, processes it, and sends commands to the actuators. Finally, a power supply provides the energy needed for a robot to operate. EUBs. Robots rely heavily on their sensors to understand their surroundings. Sensors provide the robot with data about its environment, allowing it to navigate, interact, and make decisions. Cameras are a common type of sensor, providing robots with visual information. Just like our eyes, cameras allow robots to see their surroundings. Other sensors, like LiDAR and radar, use lasers or radio waves to measure distances. This is how self-driving cars avoid collisions. Robots also use sensors to detect things we can't see with our own eyes. Infrared sensors can detect heat, allowing robots to see in the dark. Chemical sensors can detect the presence of specific gases, making them useful for environmental monitoring. Once a robot has gathered information about its environment, it needs a way to act on that information. This is where actuators come in. Actuators are the components that allow robots to move and interact with their surroundings. Motors are a common type of actuator, providing rotational or linear motion. In a robotic arm, motors are used to move the joints, allowing the arm to reach and grasp objects. Linear actuators, on the other hand, move in a straight line. Another type of actuator is a hydraulic or pneumatic cylinder. These cylinders use fluid or air pressure to generate force, making them suitable for heavy-duty applications like construction equipment. The choice of actuator depends on the specific application and the type of movement required. Section 5. The brains behind the bots. This is where programming and artificial intelligence, or AI, play a crucial role. Programming provides a set of instructions that the robot follows to perform tasks. Think of it as a recipe for the robot to follow. AI, on the other hand, enables robots to learn from data and improve their performance over time. AI algorithms allow robots to adapt to changing environments, recognize patterns, and make complex decisions. For example, AI is used in self-driving cars to navigate traffic and avoid obstacles. The combination of programming and AI gives robots the intelligence and flexibility to perform a wide range of tasks. Section 6. Robots in our everyday lives. Robots are no longer confined to science fiction movies or factories. They are rapidly becoming a part of our everyday lives, often without us even realizing it. From the Roomba cleaning our floors to the robotic arms assembling our cars, robots are increasingly present in various aspects of our lives. One area where robots are making a significant impact is in household chores. Robotic vacuum cleaners and lawnmowers are becoming increasingly popular, freeing up our time for other activities. In the future, we can expect even more sophisticated robots to assist us with household tasks, such as cooking and laundry. Robots are also transforming the way we shop and receive deliveries. Automated warehouses use robots to sort and package goods, while delivery drones are being tested to transport packages to our doorsteps. These advancements are making our lives more convenient and efficient. What do you expect for the future of robots? Share your thoughts in the comments below. Self-driving cars are no longer a futuristic concept, but are being tested and deployed in cities around the world. These vehicles use sensors, artificial intelligence, and advanced algorithms to navigate roads, avoid collisions, and transport passengers without human intervention. In the air, drones are being used for a wide range of applications, from aerial photography and surveillance to package delivery and agricultural monitoring. Their ability to fly autonomously and access difficult-to-reach areas makes them invaluable tools in various industries. Beyond our planet, robots are playing a crucial role in space exploration. Robotic probes and rovers have been sent to Mars and other celestial bodies, beaming back valuable data and expanding our understanding of the solar system. These robots withstand harsh environments and perform complex tasks, paving the way for future human exploration. The healthcare industry is undergoing a robotic revolution, with robots assisting surgeons, delivering medications, and providing companionship to patients. Surgical robots, for example, allow surgeons to perform minimally invasive procedures with greater precision and control, reducing patient trauma and recovery times. In hospitals, robots are used to transport medications, linens, and other supplies, freeing up nurses and staff to focus on patient care. These robots can navigate hospital corridors, avoid obstacles, and even call for elevators, ensuring timely delivery of essential items. Social robots are being developed to provide companionship and assistance to elderly or isolated individuals, remind patients to take their medications, and even detect signs of distress, providing a sense of security and companionship. The field of robotics is rapidly evolving, presenting both exciting opportunities and challenges. As robots become more sophisticated and autonomous, ethical considerations regarding their use and impact on society become increasingly important. One challenge is ensuring that robots are developed and used responsibly, with appropriate safeguards in place to prevent unintended consequences. As robots become more integrated into our lives, it's crucial to address concerns about job displacement and the potential impact on the workforce. However, the future of robotics also holds immense promise. Robots have the potential to solve some of the world's most pressing problems, from climate change and resource scarcity to healthcare and education. By automating dangerous, repetitive, or highly specialized tasks, robots can free up human potential and creativity. The key to successful human-robot collaboration lies in designing robots that are intuitive to use, safe to interact with, and aligned with human values. As we enter this new era of collaboration, it's crucial to foster open dialogue and collaboration between roboticists, policymakers, and the public to shape the future of robotics in a way that benefits all of humanity. The future of robotics is filled with possibilities. By embracing the potential of robots while addressing the challenges they pose, we can create a future where humans and robots work together to build a better world for all.